So good afternoon, and I hope you are doing fine. Welcome to class, and I think we could be able to start as the rest come in. So I thought we can be able to have a look at the digital inputs and digital outputs, analog inputs and analog output if the time allows us, on how we can be able to connect those devices, to interface them with Arduino, and then to be able to understand that you can actually be able to use those 4 devices to model all the rest that we have in Tinkercad, or what you could be missing out there. So sometimes we usually have sensors which are not available, maybe in Tinkercad or in the actual Arduino when you're working. So remember last time I discussed about the Arduino IDE plus its physical appearance. And therefore, today I'll just go straight to that section where we are dealing with the digital inputs and also our digital outputs, together with also the counterparts, which are actually the analog ones. So we pick the Arduino. Then we also have our small breadboard. And then our digital input is usually a button switch. So that's how you connect it on the breadboard. Even for the physical implementation on our breadboard, that's how you're going to put the button switch. We also accompany it with a resistor which goes to the ground. And that resistor, we can just retain it at 1 kilo ohm, but sometimes you can change it maybe to 10 kilo ohms, depending on your calculations. But even this one will be able to work. And then I connect down to the 5 volts, which are going to connect to the breadboard. And I power that breadboard. And I hope you could also be able to be doing the same from your side. So we have our 5 volts. I'll need to connect it to our breadboard. And then I have also ground. And we have that transformed into black or to black. Then we also have usually our button switch, you connect these lower pins, the 2 of them, terminal 1A to 5 volts, then 2A through the resistor to ground. But then 2B is the one which you usually connect to one of the digital inputs of the Arduino, and I can pick even 2. So that one I prefer to use a different color, which is green, so that it signifies that we're having a signal there. So after you are done with the connection, that's the hardware connection, you're supposed to get to the coding parts. So you go to code, then we go to text, and then you continue. And from there, of course, we have the setup section, we also have the loop section. And I would want to change all this because we have not done any coding on this. I think I can just remove everything here. And remember, we had said under the IDE, you need to look at your Arduino, you check which ports you have connected, and therefore you're supposed to declare them here. So one of the ports which I'm working with is 2, and it's basically a digital port, but you can just start by pin mode. And then into brackets, we have 2 comma inputs. because it will be giving us an input, which is either 0 or 1. And then we have the serial monitor, because you would want to view what you have actually read. So serial dot begin. You initialize your serial monitor as well. So 9600. Then when you move down, we're going to read the value that you are getting from pin 2. And how do you go about doing that? You declare an integer there. A is equals to, so those are the data structures you can use. When you are dealing with integers, you start with int. Of course, if you are dealing with decimal value, you can use double, or you can also use float. So A is equals to digital read. And we are reading from 2, so pin 2. Then you can print out those values. So serial.print, because we have declared the serial monitor, and for you to be able to print, use serial.print. Of course, that one will print for us the characters A is equals to. Then again, serial.print, I would want to print the actual value in A, and I will use serial.println. In the bracket, we have A. So that's basically our digital input. And if I start simulation, if I go to serial monitor, I will realize that the printout is getting as A is equals to 0. If I press on the button switch and hold, it changes to 1. So we're basically having our digital input, which can either be 0 or a 1. And if you want to separate the printouts, usually if you want to separate the printouts, you can take these commands. Then you have a space. So don't put anything there. And if I start simulation, you realize that it's basically separating those printouts, and I'll have a 1 there when I press on the button switch. Please note that this can be used for modeling all the digital devices you can have. So in terms of hardware, you can actually model all of them based on this, because it's basically giving you a 0 or a 1. Though you can also have it in terms of software, where you can input it from here. But this is how you use an actual hardware, which is in terms of a button switch, to implement all the digital input devices. So we can also do digital output, or sometimes we even combine it together with this one, which will be fine. I think we can combine the two of them. Now bring in an LED so that you can be able to control it using that input that you are getting from the button switch. So my LED will also be connected through a resistor to ground. And this one we usually specify as 220 ohms. If you do your calculations, you can be able to see on how 220 ohms comes about. Because yes, we'll be supplying 5 volts, and the current here should be a maximum of 20 milliamperes. So if you do your calculations, you will find that you're going to get around 220 ohms. So we connect that to grounds. And then I'll have that as black. And I'll be able to pick, just note that our anode, we can pick it from here. Then we connect it to pin 3. And I'll change that color to green as well, because we are dealing with a signal. So from there, your digital output is also connected and it's done. What you need to do next is to go to the coding part. Then you can be able to declare that pin 3 as an output, because that's what you added. So we can copy this, then we paste it there, and we're going to have this as pin 3 output, not input. So we change that to output. Then down here, we can do something about it. Like now I would want to transfer the input directly to the output, or I can invert that input and have it transferred to the output. So if I want it applied directly to the output, this is what we do. We introduce a command, digital write. That will be in small letters. So digital write. And we're going to have pin 3. That's where I want us to write the value to. And which value are we going to write there? It is actually A. So when A is 0, the LED will be off. When A is 1, the LED will come on. So if I press on start simulation, we go to your monitor, you realize that you are basically printing a 0 here. So if I change this one to 1 by pressing on it, you realize that our LED becomes, or it also comes on. So you press, the LED comes on. Why? Because you are basically transferring that input to the output. But if you want to invert, sometimes there are cases where you can invert that input. So you can use this exclamation mark. That means I have inverted the input that is going to the output. In fact, this is an implementation of a NOT gate when it comes to digital electronics. So if I start simulation like that, you realize that my input A is 0, my output is 1. It's actually coming on. So if I press on the button switch, it means that the input is 1, the output is 0, and therefore our LED goes off. So if I release, it goes back to 0, and our LED comes on.
Knock now.
Oh,
I'm sick, guy.
So that's about digital input and digital output. And I also indicate that our LED can be used to model digital outputs. Like if I want to model a motor, I will just indicate the motor is on. So you can model other devices out there. If you are missing and you are doing some projects, like now you don't have a motor which you're going to use, you can actually use this one to model that output. In which case you're going to have it coming on or being off. So 0 or 1. So let's look at the other devices, that is the analog input and also analog output. And I will create a new project. Sometimes this one you can even name it digital input. And output. So it doesn't accept that. We change this to ants. So we do a new project. Where I create new circuits. And this time I would want us to do analog inputs and output. So we take our Arduino, which is our processing device. Then we pick the breadboard, which you use for prototyping. And then we'll be able to pick the potentiometer. That's actually our analog input, so potentiometer. This is the basic device that you can use to model all the analog inputs, because it can be able to vary from 0 to 1023. So how do we connect it? This section is connected to ground. So that will be black. This one is connected to red, 5 volts. So we have it as red. And then the wiper, the one that we have here is wiper. We connect it to A0. Remember, your A0 to A5 are used to collect analog signals. So if you have analog sensors, you connect them there, and then you're able to get their signals. So then I can power the devices. And how am I supposed to do it? So these are grounds, which you can pick from here, and we connect it somewhere there. So this will be black. Then you pick 5 volts. Which goes to that lower rail, and we change that to red, and you're done. That's how we connect the analog device. So in terms of hardware, for software implementation, you go to code, then you get to text, and then you continue. And from here, we can just modify this because you're having an analog input. So we're going to have pin mode A0. That's our pin that we have used, A0 input. So you need to make sure you change that one to input. And then because I want to display the values I'm reading, so I'll do serial dot. To begin, you initialize your serial monitor. And we have there 9600. So I can eliminate everything here. And then we're supposed to be reading the value that's coming from A0. Then we store it in a variable A, so you can have it as int A is equals to analog read. You can check on the syntax. And then we have A0. So then you can print that value. So serial dot print and I'll print first of all A is equals to, then serial dot print again n A, so the values of A. Then if you want, you can actually do a space between the printouts. So remove that from there. And then you start simulation. And you realize we are getting A is equal to 0. If you rotate, it will increase up to a maximum of 1023. So that's what Arduino can be able to give us in terms of 10 bits. When you are talking about 10 bits, it will be all 10 ones, or 10 ones. So 1023, that's what you can get as maximum. So if you want to modify it, you can map it to another value. Sometimes you would want to map it. Sometimes you can even change this one to digital form, where you map it also to 0 and 1. So it will get the middle value, it changes to 1. but that I think we can do later. So for now, I would want us to apply this value to an output. And which output am I going to look for? A digital analog output. And our analog output is basically a buzzer is what I usually work with, but even the LED can work so long as because you are going to vary the brightness. So I'll pick the buzzer, then also connect it here. And this is our positive, which we go to pin, can take it even to pin 2. So we're going to have that as green, and I connect this to ground directly. So you can have it as black. So that is done. The next what you're supposed to do next is basically to declare that pin 2 because you already have A0. So I can copy this one. And then I have pin 2 as output. Then we can apply this output directly. And how do we apply it? We use, when we are talking about a buzzer, we're supposed to use tone. So you apply a frequency. So tone, and then pin 2, the frequency that you want to apply, which is in A. And if we simulate that, we're getting maximum, but that's how you apply this input manually to the output. And you realize this time the buzzer is actually working. The hardware is working, the actual hardware. It's not the, it's actually not the virtual hardware. The device that is our buzzer from the computer is working. It's being affected by what we are applying in virtual form here. So by the way, you can transform this value. Like I can transform it to between 0 and 20,000. And for you to do it that way, we declare another integer b is equals to, use the map function. So this one, I'll map the value in A from 0 to 1023, all the way to 0 to 20,000. We know that's our range of audio. So I can just be able to apply it here. But if you want, you can also print it out. And if you want to print it out, then we can copy this. So I think I can copy everything here and put it here. Then I can remove this because our space can come after. So we change this one to B. And you also change this one to B. Then we have a space and we start simulation. So you can see a value range now is higher than what we had earlier. And we have been able to map the values from 0 to 1023, what the system can be able to give us, Arduino, up to we are getting there 20,000. So you can actually be able to generate those ranges. They are different. If I want it between 0 and 1, I can also be able to map it that way. and you display the result there. So that is the much we can do about analog, though sometimes we can also be able to, we can use an LED as analog output. And if you want to use an LED as our analog output, then you connect it. So we connect the LED, and I can show you how we make it an analog output. So I'll connect that one there, and then I'll pick a resistor. Of course, we connect it here, and we said we need to give it 220 ohms. So we change that one to ohm. Then we ground this one. And please note that if you want analog output, if you're going to use the analog command, then you have to connect your device to 3, 5, 6, 9, 10, and 11 because of the PWM, pulse width modulation concept, where we are changing our digital to analog form. So that means that I have to change this to pin 3 or any of those pins which have got a tilt. Then in the code I will need to change. This time now I'm having 3 as the output. And then we're going to read our input as usual. But this time I would want to map it between 0, from 0 to 1023 all the way to 0 to 255. Because an LED can only be able to take 255 as the maximum value in terms of 8 bits. That's why when you're using an RGB LED with 3 colors, you can manage to have, you can actually manage to have up to 16 million colors from this LED. The RGB LED, usually somewhere here. This one, you can generate 16 million colors. So when you're done with that connection, you said you need to do the coding. And I think we were at this point where I've transformed A to B, which will be having 0 to 255. Then you can print out and you can actually apply. You don't turn. This time you do analog write. So when you're using an LED, you go analog write. And then of course this will change to 3. And you're going to have B, which is your value that you have transformed from 0 to 1023 to 0 to 55. So you start simulation. And you realize that our LED is maximum on brightness. But when I'm rotating the potentiometer, the brightness should be varying. And it will get down all the way to 0. So when I get to 0, the LED will be off. Though it takes a bit of time to get off, that lag, but that's how you deal with those devices. Now, we can be able to use the buzzer as our analog output. We can also be able to use the LED as our analog output. And you can see the commands you're supposed to be working with. For the LED, we have used analog, right? For the buzzer, we were using tone, which is basically a frequency that we are applying. Now, up to that point, I think I would welcome questions from the members who are attending. So if you have a question, you can ask. And remember, you can use these 4 devices to model all the other devices that you're having here. So if out there it means a digital value, then you can model using this. Sometimes you can also generate software, software inputs. And how do you generate software inputs? Sometimes actually you don't need to have this potentiometer. I can remove it. Then I will be left with LED only. Then I generate my software input. When you don't have an hardware completely, you can use now a software input. And how do we do that? You can actually use random. So we generate a random number here, a random value between 0 and 1024. Just note that this will give you between 0 and 1023 because the upper limit is not included. And it will be able to print them out. Then it can transform them into 0 to 255, after which it can apply those values to the LED. So you start simulation. And if you look at what you're having here is basically the random values. These values can only get up to 1023 maximum. Though the speed is very high, so you might not be able to see it going off. And if you want to see it going off, then you can add a delay. So you can delay here for, we delay for 1 second. So that's what I had not talked about. Because sometimes you can also, for the actual Arduino, actually it moves very fast. So you require that a delay. It will be very important that you incorporate it. So this time it will actually give us the value, then it waits for an amount of time. And you can see how it's basically changing. Changing randomly. You could also do it with the buzzer in a similar way. Sometimes you can also supply it. You can actually supply that value, in which case, how do you supply the value from the serial monitor? So we do if serial.available So if serial.available greater than 0, encapsulate that, and I close that one also. Then so we have int a serial dot we could try this. We see whether it's working. Then you can be able to input those values. So from the serial monitor, I can first of all clear what you already have there. And maybe I put 100. So you see 100, then it prints for us 24. If I put 1023, should be 255 maximum, and brightness will be maximum also. Though it waits for some time. So that's how we deal with our digital inputs, digital output, and I've given you random generation in software. You can also be able to input from the serial monitor. And I think there are a few of those concepts which most of us might have not been aware of, and we have been able to do that. So that will end the session today. If we have a question, finally, now you can ask also. So if there's no question, I can end the session there. Bye-bye. See you next time.